In this problem, we'll solve a system of equations using the elimination method. We'll solve the system of equations 2x plus 3y equals 13 and 3x minus 5y equals 10. To use the elimination method, we look for coefficients that are opposites. We look at the coefficients of x, 2 and 3, those aren't opposites. The coefficients of y are 3 and negative 5, those aren't opposites. So I'm going to need to multiply the equations in some way in order to make one pair of those coefficients opposites, so that when I add the equations together, they are eliminated. Their sum is 0. I could choose to eliminate x. I'm going to choose to eliminate y because they already have opposite signs. If I look at 3 and 5, I notice that their product is 15, and I can multiply the first equation by 5 and the second equation by 3, and I would have opposite coefficients. So I multiply the first equation by 5. 5 times 2x is 10x plus 15y equals 65, multiplying each term by 5. The second equation I will multiply by 3. I would have 9x minus 15y equals 30. Now I have 15y in one equation and minus 15y in the other. So that when I add, I have 10 plus 9, which is 19x, 15y minus 15y, which is 0, and 65 plus 30, which is 95. To solve for x, I divide on both sides by 19, and I have x equals 5. Now this is just one coordinate in the order pair that I need as a solution, so I need to solve for y. To solve for y, I substitute 5 for x in either of these equations and solve for y. I'm going to use the first equation, and I have 2x plus 3y equals 13. Substituting 5 for x, this gives me 2 times 5 plus 3y equals 13, or 10 plus 3y equals 13. Now I subtract 10 from both sides of the equation, and I have 3y equals 3. Dividing by 3 on both sides, I have y equals 1. So I have a possible solution of 5, 1. And to check it, I substitute 5 for x and 1 for y in both of these equations. It makes both of the equations true, so I will state that the solution is the ordered pair 5, 1.